Under 4.3, we need to understand about the double angle formulae. And the double angle formulae is sine 2a, which we are told is equals to 2 sine a cos a. And I feel that before we know how to use this, we need to understand how this comes about. And I would want to draw your attention to the previous videos. One of it talked about the sine of a plus b to be equals to the sine of a cosine b to be equals to the sine of a cosine b plus the cosine of a sine b. And at that point, we may want to believe that if we have sine 2a, then instead of bringing or inviting b here, we may as well have sine a plus a, such that everywhere we are having b, we write a, and therefore sine a plus a, which is basically sine 2a, then it gives us sine a cos a plus cos a and sine a. And this is easily sine 2a becomes sine a cos a plus cos a sine a. This is the same as this and gives us 2 sine a cos a. And that is how easily it can be proved. But it is the cosine of 2a that we need to take some time in, because we are told that the cosine of 2a is exactly equals to the cosine squared of a minus the sine squared of a, which is also equals to the cosine squared of a minus 1, the cosine squared of a minus 1, which is, or rather 2 cosine squared a minus 1, which is also equals to 1 minus 2, the sine squared of a. It is our duty to prove this. And basically, using the same kind of approach, we knew from the beginning that the cosine of a plus a now, because we have just substituted b with a. According to our primary knowledge, this is supposed to be given by the cosine of a cos a cos a, of course, minus sine a sine a. Remember, if this was b, we should be having cos a cos b minus sine a sine b. But look what we have. This is already the cosine of 2a being equals to the cosine squared of a minus the sine squared of a. And already this proves the first statement. How then do we get the others? Because we need to prove that the cosine 2a is also equals to 2 cosine squared a minus 1. But the fact that we are having a minus 1 and the cosine squared, from the very primary understanding, which says, which we know from the sine squared of a plus the cosine squared of a giving us 1, it follows that we can express the sine squared of a to be equals to 1 minus the cosine squared of a. And in this one, when we have the sine squared of a, the sine squared of a, it means we can substitute the sine squared of a here. And again, the cosine of 2a is going to be the cosine squared of a minus 1 minus the cosine squared of a. That is true. If you open this bracket, you're going to have the cosine squared of A minus 1 plus, because of minus times minus, the cosine squared of A. And the cosine squared of A plus the cosine squared of A, this one gives us 2 the cosine squared of A minus 1. And again, as you can see, this one now, it proves the second statement. Moving further, I believe we can also, the same way we have made sine squared of A the subject of the formula, we can still make the cosine squared of A the subject of the formula and have the cosine squared of A is equals to 1 minus the sine squared of A. And this part can now be substituted in this part, because the cos 2A is cosine squared of A, which is partly this, which is equals to 1 minus the sine squared of A, of course, minus this part, the sine squared of A, giving us 1 minus 2 sine squared of A. And that also tells us is equals to the cosine of 2A. And this, if you look at critically, you'll realize that it proves the third statement there. But it is the tan 2A, it is the tan of 2A, if we can just write it over here, it is the tan of 2A which we now need to express so that we can highlight all of them and write them properly. If you talk about tan A plus B, this one is supposed to be given by the tan A plus tan A all over 1 minus the tan A tan A, according to the previous understanding, which gives us basically 2 tan A over 1 minus the tan squared of A. So by the time we summarize this, then we are going to say so much, and we are going to use them in example that follows, example 7, moving forward. It is important to know how they come about. You can already see on page 78, this is given, this cosine 2A is also given, and the tangent of 2A is also given in terms of 2 tan A all over 1 minus tan square A. But I felt it is important to understand where they come from and how we